Hey everyone, it's Lee Halliday, and today we're going to talk about the Apollo CLI tool. And the reason we're going to do that is because imagine we're building a TypeScript React application that uses a GraphQL API. So we have our queries which give us data back, and we have to sometimes give them variables so that they can execute those queries. So why would we write out by hand the types for both of those when GraphQL is already typed? Better to use a tool like Apollo CLI to just generate the types for us. So that's what we're going to look at today, how to use the Apollo CLI to automatically generate our TypeScript types. So this is the small GraphQL API I'm working with today. I've got it running locally just within an Next.js app, and it's got literally one query. So you can ask for names, but you have to search for something, the letters in the name. So we're going to search for L, and we get back my name. Maybe we search for MA and we get back a few names. So that's the extent of our GraphQL API. But we're going to generate the types for what it gives us as a response and also what we need to give it in terms of the variables here. So why don't we go implement this query within our React app to start. So again, inside of Next.js, it's a very simple application where we're working on the home page. This is the extent of our home page right now. I've already imported the useQuery hook and GQL from Apollo client. So we can say here that we're going to write the home query, and that is a GraphQL query. So whenever you're working with automatic type generation, you always want to give your query a name. So we're going to call this the home query, just like that. And we can ask for names, and names requires an argument or a field passed into it, a variable. So we are going to say here that we have to pass in search, but we don't want to hard code search like MA. We want to take in a variable. So we're going to say it's going to take in a variable called search. So whenever you say it's going to take in a variable, you have to define the variables up here. So we're going to say that the search variable is a string that's required with the bang there. So that's our query. Let's go use it. So we're going to say const. It will give us data and say loading back from useQuery, the home query, just like this. And to keep things simple, why don't we just display what it gives us back? So we'll put this in a pre-tag, and inside of here we'll embed json.stringify the data with 2 spaces. So we could get a little fancy and say if loading or not data, return loading, ... Cool. So if it gets down here, we should have data to work with. Come back here to our React app, and it says loading and nothing. So let's see what I screwed up. All bad request. I did something wrong. Oh, I know why. I didn't actually pass in any variables to my query. So if I were writing TypeScript, it would have stopped me. So why don't we do that right now? We'll pass in our variables. So the variable we want is search, and we're going to say that it's MA. Do that. See what we get back. And there we go. So it's working now. So we have our names that are coming back from our GraphQL API. But here's the problem, and I just forgot to pass the variables in. But if we were to look at data, for example, it's any. And what variables does it want? Well, we know here, but there's no sort of type assurance. So if we pass in the number 3, it's not going to tell us like, hey, see, it's failing here because we passed in a number for our variable. TypeScript's not telling us that there's an issue. So the way you do that is you can pass in 2 type hints here. One for an interface that represents the response from the query, and another that represents the variables that it's going to receive. But we're not going to type those out by hand because we're going to use the Codegen tool to generate it for us. So we're going to start by going into the console. Let's just clear this out. And we're going to start by using yarn run Apollo. And this Apollo CLI, it comes from in a dev dependency right here. So Apollo is installed as a dev dependency, and that allows us to run something called client Codegen. But you have to pass a ton of options to this. So if I were to just run it, it's going to give me an error. It's missing a target. So let's start to fill in the options it needs. So target, we're going to do TypeScript. Flow is another option, but TypeScript is what we're working with. We have to point it towards the schema, and it just so happens that I have my schema right here locally. And the reason I have this is because I'm working with type GraphQL, and when you set up your schema, you can say emit a schema file, and I'm basically emitting this whenever I'm in development mode. So whenever I'm working and changing the schema, emit it. So it's here. So that allows me to basically point this command to my local schema by using the local schema file, schema.gql. So we'll talk about what to do when you're not running your GraphQL API within the same repo. Maybe it's hosted in another app. We'll get to that in a second. We're going to say output flat, and that will take all of these types it's generating and put them in a single folder rather than sort of putting them throughout our application right beside the code that's using them. It's up to you, whatever you prefer. We can tell it which files to look at to try to generate these types. So we're going to say that it includes, and we're going to say look in pages or src ***. So any file within those. And we're going to exclude src generated, because that's where we're going to put the types that are generated. So the last thing you need to pass in is basically just where to put the files that it's going to generate, and we're going to put them into src generated. So if I run this, what it's doing is it's looking through your entire code base in this includes folder, and it's trying to find any queries that you've written. So we wrote one query on our home page, so it's going to find that, and it's going to use the schema that we've had generated, this one that says you've got a query called names and it returns an array of strings. And what it will do is it will generate you basically one file per query or mutation that you're executing. And the cool thing here is that it gives you basically two interfaces that it exports. The first is what is the response type of the query itself. So here we're getting names, which is an array of strings, and what are the variables that this query wants to receive. So it wants a search variable that's a type of string. So what we can do with this here is go back to our code and we can import them. So import from src generated home query dot, yeah, that's good, like this. And what do we want to import? We want to import these two interfaces. So we'll come back here, put them in. So with these, we can copy and paste them and pass them into our useQuery hook type hints. So now, if we were to change this to a number, now it knows what it expects as the variable. So the first one is the response type, the second one is the variables that it wants. Here it's saying, wait a sec, search should be a string. You got past us a number, so it will actually give us an error. And if we were to do something with our data, like try to access data dot, see it knows that there's names. If we were to access data.people, it's going to give us an error saying, hey, people doesn't exist on this. If we were to look at data, it will tell us exactly what it wants. If we were to sort of go to the definition, we can see what we're going to get back. So if you change this, you're going to want to rerun that command. There's a --watch option you can pass to it to basically just keep watching for changes. But that's it. So that's how you can generate types and then use them within your Apollo queries and mutations so that you have type safe responses and variables. But imagine if we didn't have a local schema file. So there's actually another command we can run, and that's yarn run Apollo client download schema, and where we can point it to an endpoint, it will download us the schema file. So what we could do is we could say endpoint is HTTP localhost 3000, and mine's located at /API/GraphQL, and we could say output this to just say output.gql. So we'll run this. It will make a request to our GraphQL server that could be running anywhere, and it will download and output this GQL file. So if we were to go here, I now have the same sort of, it's got a few extra directives at the top. Those we're not even using. What's important here is this is the schema for our GraphQL API. So you don't actually have to download, point to the local file, and then generate them. What you could actually do is just go up to your original one, and if I just scroll back quite a ways, so instead of local schema file, we can actually just point this directly at an endpoint. So we can say just point directly to HTTP localhost 3000 API GraphQL, run that. It's going to sort of do that same thing, but in one step instead of two. Now I like to have my schema file committed, because then you can just always point it to the local file, and it's quite a bit faster in that case. And it's a nice reference for the developers if they ever need to go look at the schema that they're interacting with. It's here, but it's not a requirement. So you can just point your client Codegen to your endpoint and you're good to go. And then it will generate you the same sort of query and query variables. And I mentioned the name was key because the name that I give this query here, home query, is both the name of the file and the name of the interface. So you want every query and mutation that you're running on your site to have unique names going on. Global types, I don't have any here. And it's actually failing because you're supposed to export something from a file. But this is where all the enums and the input objects for your GraphQL API would be placed. So we just won't worry about that for now. Cool, and that's what I wanted to cover. The last thing I would recommend, so I'm just going to delete this output file. I would recommend adding them in as scripts. So come here, take your command, and you could call it like Codegen, and then paste this in. You're going to have to escape the double quotes because we're in JSON here. And there we go. So now we could just go yarn Codegen, and you don't have to memorize that huge crazy command to actually do this. And you could also say Codegen, you could add in a -- watch, and now it's just going to sit there listening for changes, new queries, etc. that you're going to do in your app. Awesome, that's what I wanted to cover. This was a very simplistic example. If you're still sticking around, I just launched a full course called Next Level JS, where we're building a full stack application, TypeScript, Apollo, front end and back end, where we use this same sort of TypeScript type generation using the Apollo CLI. So if you want a larger example with lots of mutations, inputs, responses in different ways, check this out. It's $50. I'll put a link in the description below. I would appreciate the support. It was a lot of work, but I'm very proud of it. Thanks everyone. Have a good day. Bye.